students. In previous class, we studied about the wave symmetry and we saw the numericals of that also, and then we studied about the Fourier spectrum. Right? The Fourier spectrum is nothing but a plot which contains two plots. That one is the amplitude spectra and another one is the phase spectra. So based on that, we have two plots. One is amplitude versus frequency of the Fourier coefficient, and we have another one which is a phase coefficient versus frequency. So combined they are called as Fourier spectra that we studied in previous class. Now today we will be solving few numericals, that is one of the numericals based on the Fourier spectrum. Okay? So let's start our class. The numerical is obtain the exponential Fourier series. Obtain the exponential Fourier series of the waveform and also draw the frequency spectrum and also draw the frequency spectrum. The frequency spectrum is nothing but it is the Fourier spectrum. Okay, now we call it as frequency spectrum because both the plots, that is amplitude plot as well as the phase plot, are plotted versus frequency. So that is the only reason we call it as frequency spectrum also. Okay, so we'll be plotting the frequency spectrum and the waveform given is this is x of t minus 2 pi minus pi 0 pi 2 pi. So these are the points, that is minus 2 pi, minus pi, pi and 0. Then it starts from here, it goes up, then it comes down till here, then it goes up a square wave. Okay? So it's a kind of a square wave whose value, this value is minus a and this value is plus a. So this is definitely a periodic signal, as we have seen. It repeats, as we can see that it is repeating after an interval of 2 pi. 2 pi is its period, the fundamental period, and after 2 pi it is a repetitive. So we can directly write t as 2 pi and our omega naught will be 1. Since it is 2 pi by 2 pi, it will be 1. So we can easily even define x of t. X of t is what? It's a between 0 to pi and it's minus a between pi to 2 pi. Here it is a between 0 to pi and it is minus a from pi to 2 pi. So we have defined our x of t. What it is asking us to obtain is to obtain the exponential Fourier series. Now to obtain the exponential Fourier series, what are the coefficients basically? In the exponential Fourier series, the coefficients are C0 and Cn. That we should know. And we should know the formula of C0 and Cn also. Now here the T0, the limit of the integration T0 we are taking is 0 and then T0 plus T, it will be 2 pi clearly. Okay? So these are the limits of the integration. Then we have to calculate C0 and it is 1 by T, T0 to T0 plus T, x of T dt. This is what is the formula for C0. Okay? And it is same as the formula of small a naught and capital A naught. Now just applying the things over here, that is t naught to t naught plus t naught. We have two different limits, that is 0 to pi, the value is different, and pi to 2 pi, the value is different. So we'll have to bifurcate it. Now since t is what? T is 2 pi, we can directly write it as 1 by 2 pi. Okay? 1 by 2 pi, this becomes 0 to pi. 0 to pi, it is a dt plus pi to 2 pi, it's minus a dt. Now what would be the value of C naught? Just calculate and give me the answer. Fast. Do fast everyone. This one is very simple. Just give me the answer of this integration. 1 by 2 pi, I have taken two limits. 0 to pi, it is a dt, and pi to 2 pi, it is minus a dt. So what would be the value of C naught? Finally C naught का answer कितना आएगा? जल्दी से बताओ. I'm not going to do this. Give me the answer of this integration. Fast, calculate and do it fast, students. जल्दी से reply करो. I'm waiting for your answer. Yes. Yes, we'll proceed further. Reply fast. Minus a by 2. Is it minus a by 2, everyone? No, it's not minus a by 2. It is 0. Correct. It is 0. C naught coming out is 0. So this is the first part that we are getting. C naught will be 0. Now coming to the second part, C of n. We have to calculate C of n, and the formula is 1 by t integration. Again, it is t naught to t naught plus t x of t. X of t into what is it? Is e to the power minus j n omega naught t dt. So this was the formula for Cn that we studied in previous class. Now we have to just apply the values that we are having here. Then Cn will be 1 by t is 1 by 2 pi. Now we have the integration limit again. We'll take it in two parts. 0 to pi. 0 to pi, x of t is a, e to the power minus j n omega naught is 1 j n t dt. Okay? So this is my first part. Then the another part is plus pi to 2 pi. It's minus a e to the power j n t dt minus. Okay? So this is the second part. So we have to take two different parts as we are having two different values here. Now what would be the answer of Cn? 1 by 2 pi. Then this one, as we can take a outside entirely, throughout from this integration as well as from this integration, we can take out a outside. Okay? Now inside it will be, if I am taking this one, e to the power minus j n t by minus j n with the limits 0 to pi. Okay? Now this one, another one is e to the power minus j n t. Minus was already there, and this is minus j n, and the limit will be pi to 2 pi, and the outer bracket. So this is how the integration will be. Okay? And we have to just take the apply the limit 0 to pi and pi to 2 pi here, and it comes out as Cn after applying the value of e to the power j n pi, e to the power minus j n pi, and it is nothing but e to the power minus j n pi is minus 1 to the power n. Okay? To the power minus j n pi is minus 1 to the power n minus e to the power, here minus is also taken out. From here also I am having minus j, here also I am having minus j. So I am taking minus a outside, minus by a by 2 pi. This becomes minus 1 to the power n, and this is e to the power 0. Then minus, okay? This is again e to the power minus j n 2 pi. 2 pi का मतलब क्या हो जाएगा? it will be again e to the power minus j and 2 pi, and this is since it is e to the power 0 तो ये आपको already 1 हो जाएगा, and this is e to the power minus j and pi, this becomes again 1, ये 1 हो जाएगा, and then plus this is minus, and then here again it will be minus, मतलब e to the power minus j and 2 pi again will be having one more minus. Let me write one more step of it, then it will be better to know. Okay, this becomes e to the power minus j and pi minus e to the power 0. Okay, now this becomes e to the power minus j and 2 pi. Now minus is already there, minus e to the power j minus j and pi. Here now, so here I am having two terms of minus e to the power minus j and pi. Now this can be written as minus a by 2 pi. Further, as I have already said, this becomes minus 1 to the power n. This is e to the power 0 is 1. Then minus e to the power minus j and 2 pi will also be 1. And then plus, this is again minus 1 to the power n. Okay? Now after solving this, Cn, after solving this, Cn becomes, here in the numerator we are having Jn also, right? Sorry, denominator we are having Jn also. ये आपका Jn will be also taken out. Wait, I just forgot to write. This is Jn. We'll be having Jn term also. Jn 2 pi. Okay? Then this becomes minus a by Jn pi. Now these values are 2, minus 1 to the power n, minus 1 to the power, that is 2 into minus 1 to the power n, minus 2 हो जाएगा. So inside it will be minus 1 to the power n minus 1. Now this is going to be the value of Cn. ये हमारा Cn हो जाएगा. ठीक है? So this is going to be the value of Cn. Now accordingly, since I have got the value of Cn and I have got the value of C0, दोनों we have calculated. Now accordingly, we'll write the exponential Fourier series, and then we'll plot the spectrum of it. The exponential Fourier series will be Cn will have the further value of Cn for different values of n, whether n is a positive value or n is a if n is a odd value or n is an even value. Now if n is an odd value, अगर minus 1 to the power 1 होगा, तो what it will be? Minus 1, this becomes minus 2. Minus 2 हो जाएगा, it will have different value, that is minus will get cancelled out, this becomes 2a by j pi. Clear? Accordingly, we can write it as if Cn is minus j is taken up. This here j is in the denominator, j is taken up. This becomes minus j, and it is 2a by n pi for odd values of n, and it will be 0 for even values of n. Definitely it will be 0. Agar minus 1 to the power 2, 4 or any value that even value we are taking, this becomes 0. Okay, because this is 1 minus 1 and it becomes 0. So we have to take it differently. For odd values of n, Cn will have this value, and for even values of n, it will be 0. Now we can write our x of t. Since C0 is 0, C0 0 है, so we don't have to worry about C0. Then accordingly we can write. Now actually the formula for xt is C0 plus summation n minus infinity to infinity. What is it? Cn e to the power jn omega naught t. ये formula होता है. Now we have to keep the value C0 0 है, so this becomes x of t equals to summation n minus infinity to infinity. This is our Cn. Cn is minus j 2a by n pi into e to the power j n t. Omega naught is 1, so we have taken this value, and this will exist only for odd values of n. This will exist only for odd values of n. So this is our xt. Now after this we'll have to plot. Okay? Now we'll be calculating the values of different values. Now we have got c naught as 0. ठीक है. Now since this is our Cn, ये हमें यहीं से मिल जाएगा. For Fourier spectrum, we'll have to find out the values of C1, 2, 3, 4, and 5. Now we already know that it's an amplitude. If you are plotting amplitude spectrum, then it is symmetric about the vertical axis. So whatever it is, C of +1 or C of -1 will also be same, and then C of +2 or C of -2 will also be same. C of +3 and C of -3 will also be same. So we don't have to worry about it. Let us calculate C of 1 or C of -1. ठीक है. Now if I am taking it as 1, what is it? कितना आ रहा है? We have to take the magnitude actually. हमें इसका magnitude लेना है. We have to take the magnitude of C of 1 and C of -1 for amplitude plot. Now if I take it 1, what is it? It will be -a by 2 pi. क्या आ रहा है? अगर ये -j है, if I am taking तो माइनस तो नहीं रहेगा because it is an amplitude. It will be just 2a by pi. हो जाएगा. We have to take the amplitude only. It will be C of 1 and C of -1. It will be 2a by pi. Now it doesn't exist for odd. It doesn't exist for even values. So directly we will calculate C of 3 equals to mod of C of -3. It will be 2a by 3 pi. ठीक है. So it will be 2a by 3 pi. That is, we have to take the odd values of n because it doesn't exist for even values. So this is the first value, this is the second value, and we can further write the other values also. That is C of 5 and C of -5, and accordingly. Now if we plot it, this is versus omega. We don't have to forget this thing that it will always be versus omega. ठीक है. And here n value 0. This is 1, 2, and 3. -1, -2, -3. What is the value at n equals to 1? Here it is 2a by 5. Then the value will be 2a by 5. Here also it will be same. That is 2a by 5. Now if I am plotting for 2, I don't have any value at 2. Here it is 2a by 3 pi. 2a by 3 pi will be a lesser value. 2a by 3 pi. Here also it will be 2a by 3 pi. ठीक है. So this is how we can plot the amplitude spectrum. Is this part clear everyone? यहाँ पे clear है सबको? Amplitude spectrum is clear or not? ये बहुत सिंपल है. We just have to calculate the values of Cn. ठीक है. हमें Cn भी आपका क्या है? Mod of Cn versus omega. Mod of Cn versus omega. So we have to take the mod values of Cn, that is amplitude of Cn for the different values of n. n की अलग-अलग values पे कितना आता है. Clear? So for n1 we are getting certain value. For n3 we'll be getting certain value, and accordingly we'll be getting it. Clear now? So that is how we'll plot our amplitude spectrum. Now we can even plot the phase spectrum for the same thing. यहाँ तक clear है कि नहीं सबको? Just tell me everyone whether this till here it is clear or not. Is it clear, students? I'm asking you. We'll have to calculate the values. That is, हमें Cn calculate करना है, C0 calculate करना है, and we'll have to write this one. ये आपका exponential Fourier series है. ठीक है. ये काम यहीं पर खत्म हो गया. Exponential Fourier series लिखा, till here the work is over. मतलब half work is over. It is asking us to plot the Fourier spectrum also. Fourier spectrum मतलब it will be plotted with the value of Cn. Cn की value से हम plot करेंगे. Clear? Now since we have got the, we have to calculate the amplitude. Amplitude मतलब हमें mod of Cn calculate करना है. It is always mod of Cn versus omega. ठीक है. Now for Cn, as we have got these this as a Cn minus j 2a by n pi for odd values of n. It exists only for odd values of n. So we'll be calculating C1 and C of minus 1. That is the magnitude. हमें सिर्फ उसका magnitude ही निकालना है. So it will be 2a by pi. Will not worry about j because we don't have to take that thing because ठीक है, we have to just take the magnitude. So it will be 2a by pi if n is 1. Similarly, we will calculate C mod of C3 and mod of C of minus 3. So it will be 2a by 3 pi. Okay. Similarly, we can even find the pi n equals to 5 value. That value will be 2a by 5 pi, and we can plot it accordingly. This part is clear or not, students? First tell me, then I will proceed further. Shall we proceed or you want me to repeat? It's clear now, everyone. It is not very tough. You just need to understand the thing how to plot it. Clear? Now we'll have to plot the phase also. अगर जब हमें phase plot करना है, this is our Cn. How do we plot phase? Now since Cn, what is the value of Cn that we know in terms of An and Bn? Because we'll have to find the phase of Cn, right? Phase of Cn can even be calculated by this one. इससे हम calculate कर सकते हैं. Here we don't have any real term. This is what? That is an by 2 minus j bn by 2. Cn क्या होता है? an minus j bn by 2. This was the value of Cn that we calculated. We have already found this one in previous lectures. So if we write it in this term, this one can be, we don't have an by 2 term here. We don't have an by 2 term. Here j minus j is already there. Then we have Pn term. Pn is 2a by n pi. So what is it actually? If we calculate the theta, and it is what? Minus tan inverse Bn by an. Right? We already know that is minus tan inverse Bn by an. If you have to calculate theta n. Now by this formula we can calculate. If I take Bn by an, Bn is what? 2a by n pi, and an is 0. Then it will be what? Minus pi by 2. होगा? It will be minus pi by 2 for the value of n. अगर मैं कोई भी value लूँ, if it is 1 or minus 1 or कुछ भी लूँ, because an is 0, it will always be minus pi by 2 and plus pi by 2. दोनों में से ही आएगा. Because we know that its phase spectrum is always antisymmetric. Phase spectrum is always antisymmetric. So if I am plotting the phase plot, अगर मैं phase plot करती हूँ, so in that case this one is becoming minus pi by 2. Then the other value, this is phase of this. मतलब if I am taking n value as 1, here if it is minus pi by 2, then for this side it will be pi by 2. ठीक है? तो this is going to be my phase plot. ये मेरा phase plot हो जाएगा. Because it is always antisymmetric, that will have to assume कि अगर n की value is plus 1 है, तो it will be minus pi by 2. And if I am taking n की value as minus 1, it will be just pi by 2 because here it becomes minus pn by an हो जाएगा. ठीक है? And that will be pi by 2. Clear? So that is how we'll have to consider it. And this side it is minus pi by 2, this side it will be plus pi by 2. And for all the values of n, this will be same. That is minus pi by 2 plus pi by 2. Minus pi by 2 plus pi by 2. That will be same. This side it will be minus value. This side it will be plus value. Is this part clear again? The phase plot is also clear to everyone. This is what we'll have to understand कि आपका Cn किस form में दिया है. That should always be an by 2 minus j bn by 2, and by this formula we can calculate the theta n. ठीक है? And theta n we can even plot by the different values of n पे, whether it is what. मतलब basically ज़्यादातर आपका minus pi by 2 और plus pi by 2 में ही उसका result रहता है. Clear? Or it may have the values in points or some other value as well. Clear now? Clear? The phase plot is also clear to everyone. I don't want any confusion in this because this is very important part, and the Fourier spectrum comes in the further semester also. जब आप digital signal processing पढ़ोगे तो ये सबसे important part रहता है, and it always comes in the exam. The part is clear or not? The concept is clear or not, students? Tell me. You want me to explain it again or not? Is it clear now? Okay. Chalo, let's start with the another topic. I'll give few more questions based on it for your practice. If you find any difficulty in obtaining the Fourier spectrum or plotting the Fourier spectrum, you can just you can just contact me anytime. You can just get in touch with me. कुछ भी मेरे से वो पूछ लेना, ठीक है? अगर कोई भी problem है तो, because right now we have to just cover the syllabus because of your city dates has come. ठीक है? Now the next topic that we'll be studying today is the power representation. Power representation using Fourier series. ठीक है? Power representation using Fourier series. Power representation using Fourier series is again an important topic, and you will even get the questions based on this. Now, how we can represent the power using Fourier series? Now, we already know if the instantaneous power of any signal, the instantaneous power of any signal, if the signal x is given to us, and if we have to calculate the instantaneous power of that signal or the mean average power of the signal, that will be given as mean power is over a period of time, it's 1 by t, 0 to t, x square t dt. So this is the formula for calculating the mean power of any particular signal over a period of time. मतलब एक particular period of time के लिए if we have to calculate the power, it will be 1 by t integration 0 to t x square t dt. ये हमने already पढ़ा हुआ है first unit में. ठीक है, दैट इज पावर सिग्नल जब हम पढ़ रहे थे तो वी हैव ऑलरेडी कैलकुलेटेड दिस पावर सिग्नल में हम पावर कैलकुलेट कैसे करते हैं. सो दैट इज फॉर अ पर्टिकुलर पीरियड ऑफ टाइम 0 टू t x स्क्वायर t dt. ठीक है, नाउ विद दिस वन वी कैन इवन राइट मीन पावर ओवर अ पीरियड ऑफ टाइम is given by, if it is in terms of Fourier series, then it is a naught cos square, that is trigonometric Fourier series, plus summation n 1 to infinite an square by 2 plus bn cos square by 2. ठीक है, so what is the formula? A naught cos square plus summation n 1 to infinity, n is 1 to infinity, and inside the summation over a bracket it is an cos square by 2 plus bn cos square by 2. So this is what we need to just remember if it is in terms of Fourier series. If the power representation is given in terms of Fourier series, because we have already calculated the value of a naught, an and bn if it is a trigonometric Fourier series. ठीक है, तो a naught, an और bn का वैल्यू हमें पता होता है, and accordingly we can calculate the mean power over a period of time for a particular period of time. ठीक है, now this is what, this is a naught is what, dc term का square, it will be a dc term का square, plus then here will be having the cosine term का जो square का जो average रहेगा and the sine term की coefficient का जो average रहेगा, that will be taken in this way. ठीक है, now let us solve the question. Question is very important to solve. Now I write the question here. Find the average power. Find the average power of the signal xt, which is given by cos square 5000 pi t into sin 20,000 pi t. Now this is the xt given to us. We have to find the average power of the signal. Now in this one, if the signal is transmitted If the signal is transmitted through the telephone system, which blocks, so this is an important part, which blocks DC and frequencies, जो DC को ब्लॉक करता है और frequencies above 14 kHz. मतलब if any of the signal का कोई भी part 14 kHz से above है, then it will block that one and DC को भी वो block करेगा. ठीक है? If the signal is transmitted through the telephone system which blocks DC and frequencies above 14 kHz, then compute the ratio of received power to transmitted power. To transmitted power. Okay, now this is the question. From here we have the question, okay, and that part. We just need to understand the question क्या है और आपको निकालना क्या है, ठीक है? What is this given is average power of the signal, हमें निकालना है, and the signal given is cos square 5000 pi t sin of 20000 pi t. This is our signal. If the signal is transmitted through the telephone system के through transmit हो रहा है, it is blocking DC and the frequencies above 14 kHz. ठीक है? Then we have to compute the ratio of the received power. मतलब हमें received power भी calculate करना है, transmitted power भी calculate करना है, and then we have to obtain the ratio of both the powers. Now let us solve the question. We all know cos square theta can be written as cos square theta को कैसे लिख सकते हैं in terms of sin? How can we write cos square theta in terms of sin? Yes? Anyone who can reply, just turn on your mic and give the answer of this question. 1 minus s. What is it? 1 minus और sin cos के टर्म में sin और cos के टर्म में? No. Cos square theta I'm asking. It is 1 plus cos to theta by 2. Right? It is 1 plus cos to theta by 2. मतलब basically हमें वो square term को eliminate करना. We'll have to remove the square term because this one is cos square term and this is directly sin term. So that can be written as 1 plus cos to theta by 2. Now we can write our st as 1 plus cos to theta can be what? क्या हो जाएगा ये? 1 plus 10,000. ठीक है? 1 plus 10,000 pi t by 2 into sin 20,000 pi t. So this is going to be our cos term. Now we'll take it individually. Xt can be written as 1 by 2 sin 20,000 pi t, this part, plus 1 by 2, this is sin of 20,000 pi t into cos of 10,000 pi t. ठीक है? Now further we can even write it as sin A cos B. क्या होता है sin A cos B? What is sin A cos B? What is it? Sin A cos B can be written as x of t. This part is as it is 1 by 2 sin 20,000 pi t. ठीक है? That can be written as plus 1 by 2. This is sin of a plus b. Sin a cos b is sin of a plus b plus sin of a minus b. So a plus b by 2. Sin of a plus b by 2. 20,000 pi t plus 10,000 pi t will become sin of 30,000 pi t by 2 plus sin of 20,000 pi t minus 10,000 pi t will be 10,000 pi t by 2. ठीक है? So we have bifurcated it, that is sin a cos b वाला formula. It is sin of a plus b by 2 plus sin of a minus b by 2. Now further I can write my xc as 1 by 2 sin 20,000 pi t plus here it is 1 by 2 gets multiplied. This becomes 1 by 4 sin 30,000 pi t. Then here it is plus 1 by 4 sin 10,000 pi t. ठीक है? So I got three terms here. This one is first term, second term, and the third term. Now I have to calculate the transmitted power, mean average, मतलब mean जो power निकालते हैं for transmitted power. So the transmitted power is represented by PT. Let it be PT. So the average transmitted power ये हम already पढ़ चुके हैं. What is it? It is a square by 2 that we have already calculated and studied in first unit. So what is a here? It is 1 by 2. Here it is 1 by 4. Here also it is 1 by 4. ठीक है? So the transmitted power is 1 by 2 का square plus by 2. A square by 2 plus 1 by 4 का square by 2 plus 1 by 4 square by 2. How much it's coming? This we have already done in previous unit. First unit में कर चुके हैं कि power हमें calculate करना है for any of this kind of signal, then it is always a square by 2. Clear? That we have done. याद है कि नहीं? Just recall the things whether you have studied or not in first unit. For average power, mean average power for any signal, if it is in the terms of sine or cos, it will always be a square by 2. ठीक है? So what is a here? It's 1 by 2 in first term, 1 by 4 in second term, and again 1 by 4 in second term. So it will be 1 by 2 का square by 2 plus 1 by 4 का square by 2 and 1 by 4 का square by 2 in the third term. So what is the answer of this one? Transmitted power कितना आ रहा है? इसको बताओ कितना आ रहा है? Tell me fast. What is the answer of this question? Solve it and tell me. Yes, 3 by 16. Correct. It's 3 by 16 watt. ठीक है? Now since it's in terms of power, we will write it as 3 by 16 watt. Now this is a transmitted power. Now what is the condition in the case of transmitted power for received power? That कौन से frequency को block कर रहा है? It is blocking DC component and it is blocking the frequency above 14 kHz. तो इनमें से क्या-क्या block हो जाएगा? Which particular term will get blocked? If it is blocking the frequencies above 14 kHz, इसकी frequency कितनी है? इसकी frequency कितनी है? जल्दी बताओ. Is it above 14 kHz? Tell me fast. The first one, first term, second term, and the third term. Which will get blocked when the signal is transmitted? 1 by 4 sin 40,000 pi t. Only this particular term will get blocked. ठीक है? तो वही आपका ब्लॉक होगा because here sin 2 यहाँ पर क्या हो जाता है? That is sin of 30, this is here the frequency is 15,000. ठीक है, what is it? यहाँ पर ओमेगा नॉट लेते हैं. ओमेगा नॉट is what? It is 2 pi f. Omega is always 2 pi f. Here we are not taking the angular frequency. The frequency is 2 pi f, and what is it? It is in terms of 2 pi is already here, so it will be 15,000. This one is 15,000 and it is greater than the frequency which is blocking. So 14k के above की जो frequency उसको block कर रहा है. Here this term will be passed, even this term will be passed, and only this term will get passed. This term will get blocked. सिर्फ ये वाला term block होगा. Because the frequency is 2 pi f, 2 pi frequency हम लोग लेते हैं तो here it is 30,000 pi given. So what is the frequency here? Frequency is 15,000. That is 15k hertz से ऊपर है. Is this thing clear now? So only the term, this one will get blocked. The received, that is the signal which is received, will have only this term, that is 1 by 2 sine of 20,000 pi t plus 1 by 4 sine of this one 10,000 pi t. ठीक है, only these two terms will be there when it is received. Now what is the power of this one? That is power received. ये कितना आएगा? What would be the power of this received signal? It will be 1 by 2 का square by 2 plus 1 by 4 का square by 2. Okay, now what is the answer of this one? The received power. This part is clear or not, right student? कि कौन सा आपका term block होगा? It is saying that the frequency, the term which will have the frequency which is above 14k hertz will get blocked, right? Now since here it is sine of 30,000 pi t, and what is the value? What is it? Sine of omega t. ठीक है, omega मतलब क्या है आपका? Omega is 2 pi f. And here it is given 30,000 pi. So 30,000 pi मतलब the frequency value will be 15,000. 15,000 मतलब it is greater than 14k hertz. That's the only reason that only this term will get blocked. सिर्फ ये वाला term block होगा. The rest of the term will get passed. ठीक है? Now accordingly this is the signal which is received. And this is how we can calculate the received power. What is it? How much it's coming? कितना आ रहा है PR? It is 5 by 32. Yes, it is 5 by 32 watt. And what is it asking? Find the ratio of the received power to the transmitted power. ठीक है? So received power PR by PT. ये कितना आ रहा है? PR by PT. If I have to take the received power to transmitted power, what is the ratio? Tell me fast, what is the ratio of this one? The received power is 5 by 32 and that one is 3 by 16. If I take the ratio of it, that is 5 by 32 by this one, received power by transmitted power. Is it? Yes, it's 5 by 6, correct. So the ratio is PR by PT is 5 by 6. Okay? So this is how we can solve any of our numericals based on the power given to us. इससे ज़्यादा और कुछ नहीं आता है numerical. If it is in terms of power, for the calculation of the power, it will be only the type of this. इसी टाइप का रहेगा. But the thing is, you should just remember this thing कि हमारा अगर sin और cosine के term में है, तो sin A cos B, sin A sin B, sin cos A cos B, इन सब का जो formula है, trigonometric formulas है, वो आपको पता होना चाहिए. If you remember those formulas, these are very easy to solve. Clear now? So you will be having, यहाँ पर हमने जैसे solve किया है, this was in terms of sin A cos B. Sin A cos B मतलब sin A plus B by 2 और sin of A minus B by 2 मतलब sin A plus B by 2 plus sin of A minus B by 2. This was the thing that you should remember. Then only you will be able to solve it. Because we cannot directly go into the type that it is given. मतलब ये वाला जो form है, इसमें हम नहीं कर सकते. we have to convert it into the form of this. इस form में लाना है. When we are converting it in this form, we can easily calculate power. ठीक है? तो ये आपका power हो जाएगा. Now since the question has the another part also, it is saying that if it is transmitted through a telephone system, DC component. Now here we don't have any DC component. DC component का मतलब it will just be a constant value. ठीक है? और ये पर्टिकुलर कांस्टेंट वैल्यू रहेगा. इंस्टेड ऑफ दैट इज यहाँ पे साइन टर्म है, यहाँ पे भी साइन टर्म है, यहाँ पे भी साइन टर्म है. ये साइन टर्म को छोड़कर सपोज वी आर हैविंग 3/4 और 5/6 और एनी अदर वैल्यू, दैट टर्म विल बी अ डीसी कंपोनेंट. तो डीसी कंपोनेंट को भी ब्लॉक कर रहा है. ठीक है? एंड इट इज ब्लॉकिंग द फ्रीक्वेंसीज अबाउट 14k हर्ट्ज. तो 14k हर्ट्ज में कौन सी फ्रीक्वेंसी आती है? दिस विल हैव द फ्रीक्वेंसी ओनली 10000, दिस विल हैव द फ्रीक्वेंसी ओनली 5000. Here the frequency is 15,000. So only this particular term will get blocked. Clear? So this term will get blocked and the received signal will be this one. इसमें आपका ये first term रहेगा और ये third term रहेगा. And accordingly we can calculate the formula for transmitted power as well as for received power and we can find out the ratio of this. ठीक है?